Hi everybody. Here's the movie version of the practice, I should say, the solution to the practice problems. And I hope you'll find these useful. So here we have this, we want to look at the solution to the normal distribution. We have a mean of 1,000 and a standard deviation of 125. So we're looking at the question that x is greater than 890. So we know that when we have a normal distribution, when we have greater than, we're going to go to the right, and the normal distribution is set up such that it's really 1 minus that probability if you look at the standard distribution. So that's why we're going to use that lower equals false in a minute. So let's switch over to R. Let me scoot this over. And I'm going to use P norm. And we're going to have 890. And our mean is 1,000. Whoops. 1,000. And our standard deviation is 125. The lower is equal to false, as I mentioned. Don't forget to make that all capitalized, because we're pointing to the right-hand side because of the greater than. And you'll get something like 0.8106. Okay? That's all there is to it. Just remember, because of the greater than, you're going to make lower equal false. Okay. Let's take a look at the next problem, and I think I forgot to do this on the solution set. I have the probability that x is between 900 and 1100. So there's a couple ways you could do this. What I'm going to do is do it in 2 steps. And this is pretty straightforward if you're in practice. If you're out of practice, not so straightforward. You can think about the fact that, let me just put this in a note, that the probability that x is less than 1100 is going to start at 1100 and move to the left. Okay? Similarly, the probability that x is less than 900 starts at 900 and moves to the left. And we're looking for the difference between those two. That's really the question we're trying to solve. Okay? So what I can do is write P norm 1100 and the mean of 1,000, standard deviation of 125. Now I don't have to write lower equal false because I'm pointing to the left. I can just leave that alone. And I have 7881. I'm just going to take the first 4 digits. Okay. We'll come back to that in a second. And in the second one, we're going to use 900. And let's make that, what should we do? How about 2119? Sound good? All right, and I want the positive difference between those two. Remember, it's probability. Probability is always positive. So I take big 1 minus small 1. And it's going to be 0.5762. Okay. Now, if you wanted to combine these 2 steps, that's perfectly fine. you'll get about the same answer. So not to worry. All right, good. Let's take a look at problem 2. We have a data set in the file a1.txt. There's no header. We can set it up as a range with 4 columns. Produce a range chart. Are there any out of control points? Are there any points out of limitation? Produce an X bar chart. Are there any out of control points? Are there any points out of limitation? Okay, so let's go back into R. And we're going to use our scan again. So we'll have A1 assigns scan, my fault, matrix scan. And my file is in the Dropbox. So mine will be Dropbox a1.text. And I forgot to put my and then I swear a little bit. Can't leave that out. Okay, and then number of columns equal 4. And then by row equals capital true. Because the data is in there in rows. And it read 20 items, which it should have. So if you want to just look at it, there it is. That's just all it looks like. Okay, and I want to do my range chart. So I have to load up library QCC. Okay, so I'm going to do QCC, and I'll put in A1 type equals capital R in quotes. Don't use lower r. There's actually a lower r for something else. And ncol equals 4. All right. So there you have your range chart. And let me just puff this up a little bit. So the number of groups, which is the number of rows, is 5. And there you have it. No, nothing out of whack. Okay. All right. Let's take a look at our X bar chart. So just change the R into an X bar. Aha, finally, we have one violating the limit. Yay. Okay. So we have one violating the limit. We have something wrong with our process. So we need to go in and investigate it. We still have 5 groups. Our center is 8,700. That's our mean. So that's the mean over the whole data set. The standard deviation is 5088. We have our lower and upper control limits, and one beyond the limit. So typically what you would do then is go back into the process. You might have an operator that's not doing his or her stuff. You might have bad material. You need to go back in and check what's going on. Okay. Actually, one of the most common occurring items for stuff to go wrong is stuff going on in the 3rd shift when plants used to run 3 shifts. I don't know how much they do that anymore, but that's usually when things would go on. People would get real sleepy and stuff like that. Okay, let's do problem 3, and then we'll put an end to this one, and then do the other 2 problems in a second movie. Okay, we have a binomial distribution with n equal 15 and p equal 8. My fault, 0.8. Find the probability that x is greater than or equal to 10. All right, let's go back into R. Now, this is a discrete random variable as opposed to the normal. So we need to think about this a little bit. We're going to use P binom. And when we have greater than or equal to, we are including 10. So that means it's greater than 9. So I'm going to put in 9, 15, 0.8, and lower equals false. And it's going to give me 0.9389. Okay? Now I know that some of you are non-believers, and I want to show you that I'm telling you the truth. So I'm going to do the following. If it's greater than or equal to 10, let's do this. Let's do the probabilities for 10, 11. I'm typing as fast as I can. 12. 13. 14. 'Why can't I type? There's 14. And finally, 15. And this should give me the same number. Let's see. And it did. So we know we did it right. No, I don't expect you to do that, but I just wanted you to see that I did tell you the truth. Okay? Now what's the next one? Find the mean. Okay, the mean, we love the mean. It's just n times p. So it's going to be 15 times 0.8, which is 12. And then my very favorite kind of probability, the probability that x is greater than or equal to 1, it's just 1. Let me just put this in here. 1 minus the probability that x is equal to 0, a beautiful thing. So it's just going to be 1 minus d binom 0, comma 15, comma 0.8. And before you can say rescue dog, you have 1. That's all there is. It just happened to be that term there, the d binomial, was 0. So 1 minus 0 is 1. That's all there was to it. Okay, so I'm going to stop this because I only get about 15 minutes, and then I'll do the next one.